All right, good afternoon. My name is Jim Meehan, and I most recently run product marketing at Kentik, but I've held other roles in the past. I used to head up our solutions engineering team. I want to talk to you a little bit about Kentik for service providers, which has been a big business for us historically, and we're still innovating on that front. I think the story for service providers for the last little while has been this squeeze, right? Both on the cost side as traffic volume grows and infrastructure refresh, and also on the revenue side in terms of commoditization of all the stuff they used to make a bunch of money on, right? Internet access and point-to-point and all of those things. And competition for other services besides transport and transit, over-the-top video and audio services competing with things that service providers used to offer, like cable TV, as a big revenue generator. So being able to manage both cost and revenue has really been key for service providers to stay abreast of their business and to continue to grow and innovate. And being able to do that has come to rely very heavily on understanding at a deep level what happens on the network for both cost and revenue management. And Avi talked a little bit about that. For some service providers, that looks like understanding traffic flows to see where new revenue opportunities are. So if I can look at where traffic goes beyond the edge of my network, I can identify potential new customer opportunities. I can see, there's a bunch of traffic that leaves my network to another tier one provider and then ends up on N number of remote networks. Perhaps my sales team should reach out to those non-adjacent networks, show them how much traffic they're receiving from our network, offer them a better deal, say, hey, you can get better performance too because you're removing hops out of the path. A lot of reporting in the past has been at the network identifier level. Turning this deep understanding, you don't really get it from looking at ASNs, prefixes, IP addresses, interfaces, right? That's not the type of information that's going to make sense to people who manage cost and revenue. They need to understand things like customer names, what infrastructure did that come from, which CDN provider, who was the content owner, what application types and names. And these types of things become especially important for providers who have a large residential broadband component. They're, rather than like selling wholesale, where it's important to understand, all those remote destination network things. They want to know what are the top applications that my users are using. How's that growing over time? Are there new applications, new OTT services appearing? How can I stay ahead of that? How can I manage my interconnection so that I can receive that traffic into my network at a reasonable cost and at a level of performance that makes those customers satisfied with it? So this is the type of thing, rather than seeing a time series graph that's going to show me prefixes and ASNs, those providers, they want to see a time series graph that identifies this is the Netflix traffic, this is the Spotify traffic, this is the YouTube traffic. And this is actually pretty difficult to do because a lot of this type of content, it doesn't originate from a set of IP addresses that I can say, that's, Netflix's IP space, because a lot of Netflix traffic originates from on-net caches, or if it's Akamai traffic, it originates from Akamai's own ASN, it originates from caches in other people's ASNs, it originates from caches I have on my own network. So being able to tag all that traffic from wherever it originates is a difficult problem. And some of the solutions that have been tried in the past to deal with that are like, I'm going to put all this flow data into Hadoop, and then I'm going to put a big table that maps all those IPs to what they belong to and post-process it. And then every day I'm going to spit out a report that has it, but it's not real time. And if you need to go back and add filters or whatever, that's a whole new job to run. And so there's a lot of iteration latency in trying to produce the type of analytics that these providers want that way.
Just a quick question from Jim Palmer. He's online. Is there a way to see trouble with that flow if you can see to the endpoint?
To see trouble with NetFlow to the endpoint?
Yeah, I guess navigate to the actual problem, or you don't see that?
I guess it depends on the type of problem you're trying to look at. You could see problems like a given subscriber not getting the throughput that their plan might allow, right? If the total throughput to a per subscriber is lower than what their plan is. You're not going to see like a CPE outage probably, except that the traffic to a subscriber goes away.
We see traffic, and actually the way we started was it was really focused on IP address and endpoint. By adding in the user ID, now you can know which IP addresses are used by which customer, which points to that. So we're not only focused on what are the services sitting on top. You can go the other way and say, show me everything the user is doing, which points at the end location. And generally it's congestion, throughput, or it can be attacks and problems with if they're starting to scan things or attack other customers. Those are all kinds of problems that people use the anomaly detection to find.
And I'll say, we're not reliant only on NetFlow, right, for the data inputs to our platform. We have data inputs that can look at packets or metadata as well. So one aspect of this is mapping all of the traffic to the infrastructure that it originated from, the CDN provider or the actual content owner's infrastructure. We have a mechanism to overlay CDN provider IDs as an additional field. So you can think of like the flow record being ingested into our system. We're going to add on another field or column to that flow record that identifies the CDN originator for every flow. And I'll talk in a second about how we do that right here, actually.
Just backing up on that, so that record that you're talking about, this is your own formatted record that gives you the flexibility to stick any metadata in there you want.
Yeah, it's essentially our distributed column store database that has however many columns wide we want. And we've added more and more columns over time as customers have told us about additional type of context that they want to tag on to flows they receive. So some of those are built-in columns, and CDN is one of those, but you can also add on your own custom columns for business-specific attributes that you might want to tag on to flow data, like customer names and regions and those sorts of things that are specific to each individual.
You just tell the customer what the format is of the record that's coming into them, and then they parse it out and deal with it however they need.
Yeah, the way that works for us is we've got an API that says, provide us the map of, here's the columns we already have that you could match on IP addresses or interfaces or whatever, and here's for this set of IP addresses, I want to stick this value into this other column.
So we have a couple ways of doing it. If people are pretty sophisticated, we have a library they can use where they just fill in a structure, send it to us. It's like flow with all the additional data, and they can define that taxonomy of what they want. Our first customers, all the basically SaaS companies, web companies, they use that to build Kubernetes integration and AWS integration. And then we've been saying, how do we take those things and make them push button integrations for people? Because not everyone wants to be a data dreamer gluer. I know we all want to hire those people and train those people, and that's the way that we want to be, but that's not quite the way it is today.
So yeah, it's not just that you're telling them what you're sending, they can tell you, send me this.
Yeah. Well, they can send us anything, and then they can pull anything out in whatever way they want.
Right.
So the way, for both CDN and OTT tracking, which is the ability to tag the flows with those dimensions, we've actually built an integration to DNS infrastructure within service provider networks. So if you think of a subscriber starting, they start watching a video or something, we'll see their DNS request that looks like download.updates.com or live.music.com, whatever it is they're accessing. So that gives us a DNS resolution. This source subscriber IP looked up this host name and got a response of that IP address. Then when the flow of that data subsequently starts from a CDN origin back to the subscriber, we can tag that flow using this DNS lookup that we saw previously, and then have a map of a bunch of different host name patterns that says, if the host name ends in this domain or has this string in it, that identifies a flow from a particular CDN infrastructure, or it identifies a flow as belonging to a particular content owner. So even if the same CDN cache or origin is serving music to subscriber A and software update to subscriber B, we know which content owner should be tagged to that flow because we saw a music host name lookup for subscriber A before the flow started and a software download lookup before the transfer to subscriber B.
And it's all, how do you do it without DPI, without inline boxes? At the modern scale, people have N by 10, 100, 40, 100, even faster everywhere. The DPI approach doesn't work. So how do you take the data that you're already getting, that you might be sticking into Kafka to go into a data swamp anyway, and make it useful in a live way to augment data? How do you combine the data streams to give that value without having to go down to the packet level, which is becoming increasingly harder?
So this was a real incident that happened back in September. We had a couple of customers come to us, Nanog actually, and say, hey, a couple days ago on September 27th, we saw, in the middle of the night, this huge 150 gig spike of traffic coming into our network. But we have no idea what it was for. It was an odd time of day. It came from a whole bunch of CDNs. It didn't look like a Netflix cache fill or anything like that. And we had, a couple of our customers had already deployed our OTT tracking, which identified it as gaming traffic from a couple of different services, Steam and Microsoft and PlayStation. And so pretty quickly we were able to look at the news to see that Fortnite Season 6 had been released at 9 a.m. UTC. And sure enough, that corresponded right exactly with when that traffic spike started. And it was, Fortnite's available across a whole wide variety of gaming platforms, right? So it was not surprising then that we saw all that traffic start up at the exact same time across the distribution for all those different gaming platforms. And then if you look at that as a flame graph, you can see, sort of time-wise, that there's a nice alignment of Microsoft serving that new content out of level 3 and also out of their own infrastructure, out of Edgecast. PlayStation was apparently serving it out of AWS, so on and so forth. The other thing that service providers are interested in are putting subscriber IDs onto flows so that they can make use of the aggregates later on a per subscriber basis. So one of those use cases is for customer support. If someone calls to complain that they're over quota or they're being charged for a plan overage, they want to know, the customer service people want to be able to give them some information like, here's why, right? There was this percentage of video usage, this percentage of social networking, this percentage of whatever, right? To give subscribers some information about why that happened, right? To justify the billing. And even to give subscribers self-service access to that. So imagine, logging into your mobile provider's self-service portal, and instead of seeing just you utilized 20 gigs over the last month, there's a breakdown of what type of content that was. And then there's also validating engineering assumptions, right, about across different user classes, what are the utilization percentages, and even a sort of a pricing and product aspect, right? So if I know that at the 95th percentile, users have usage that breaks down along these application boundaries in terms of how much gaming, how much video, how much service X, Y, and Z, then I can create pricing or packaging plans that are better able to monetize those different categories of users or subscribers.
Question for you on that. Does the platform have any method of, let's say you're tracking a subscriber, let's say they've got a certain, let's say data allotment and they're reaching their limit. Does the platform itself have any way to kick off let's just say they're using a Cisco router. Does it have any way to kick off some sort of process to say that for this particular user or they're identifying flow, we will now throttle your traffic, something like that?
I think that would be more automation glue across our API now rather than built into the Kentik platform. I mean, yes, in theory, you could build policies that generate alarms when, per subscriber, the total bytes over some period of time is greater than a threshold. But I think most of the customers we deal with want to use us as kind of the data aggregator, with all of that added context, and then do their own business logic across that data and integrations with automation. The last part for service providers, and I'll show you this in a second in the product, is what we call the My Kentik white label portal. So we had a lot of customers who said, hey, we love the data that you provide to us for our own internal operations use cases, but we want to show that back to customers. We want to give them a view of that data, but obviously they can't see, we don't want them to see our whole network, we don't want them to see adjacent customers. Can you give us a pared down view that's limited to a kind of a subscriber by subscriber segment? So we actually built that into our platform where you can customize a white label portal that your downstream customers could log into, and it can have your own logo on it, and you can also customize what set of reports you want them to have access to. Yeah.
For the residential customers, this one?
For what?
Residential customers you are talking about?
In theory, I think the early adopters have been more for providing this to enterprise or wholesale customers.
Otherwise, would be like 50 million customers.
Right. I mean, we have the data for residential customers. I think when we're talking about residential, it's more common for service providers, again, to want to pull the data out and present it inside of a customer portal that they already have that presents billing and other context from the account rather than just the traffic
portal
data.
for service provider usage.
Right. So as you'll see in a minute, we promise in the demo, anything in Kentik, you can go get the API call, so you can go get a graph and put it in your own portal pretty easily. We developed this for service providers that want to offer it to their enterprise customers, but interestingly, we do have enterprise where the network group uses this to provide more limited views to the application operations or the security operations. So they'll give the IP Explorer, because you can use this to limit only to seeing the data for one customer, group, application, whatever, any of those things.
Internally, enterprises can provide to their each and every business units.
Yes, because in Kentik, you can, if we don't get locked down, pretty quickly pull up all the dimensionality of network traffic and architecture, which a lot of the applications operations that think this is all API magical stuff can get lost in. So it's how do you constrain that so that people can get, oh, there's no problem. There's a problem across every application talking to this network, or there's a problem only in this application and this part to, again, it's not magically tied to APM, but giving them a view. But the people that asked us to build this where the service providers, as part of revenue, for example, taking threat feeds and using it for sales prospecting or for lead gen, which is basically like, hey, you are compromised, and then they have security offerings they want to sell. It could be done for residential or for wireless for broadband. That's not the conversations that we've had today. It's more for enterprise and more enterprises where they're managing the network than every SMB. It's just the way that it's been going so far. But this is only about 4 months old, so it's just evolving.
So this is a view that I pulled up from a live network. I wanted to talk for a second on the service provider side about something we talked about at the last network field day called ultimate exit. But we have a better live representation to show you this time. And that's the capability to take.
Can you make it a bit bigger? Might be hard to see. I might, or the white background might be easier to see. I don't know.
Oh,
I don't know.
Better.
better. Okay.
I think better. This one.
This one?
better.
Okay.
Okay.
And maybe a little bit bigger. The projector seems a little bit lower resolution. Okay.
So one of the things that we can do when we see a flow record coming in at one side of the network is using BGP and SNMP interface data, map where that flow will exit the other side of the network. So think of a big global wholesale IP transit provider, a key question that they haven't been able to answer in the past is how does one customer's traffic affect the load of the network overall? If I have a customer where most of the traffic they send into my network, I deliver out of the same POP or out of the same router that I receive it on, that customer costs me a lot less than a customer where the traffic I receive from them, I have to haul to the other side of my network and drop it off at a place where I'm going to have to pay a bunch of money both to transport that traffic and then to deliver it to the end customer.
So, quick question.
Yeah.
Instead of maybe my traffic engineering policy hot potato routing, so sending to the closest exit, maybe I am not doing this, and I can track with this one if I'm not sending to the closest exit. So if I'm not doing hot potato routing.
Right. So yeah, there's multiple uses for this. One is to resolve routing inefficiencies, right? Stuff that you thought was working one way, and you can visually see, whoa, I have traffic that is not following a hot potato routing policy. I'm backhauling it over here to drop it off. In other cases, the only path you have is on the other side of your network, and so that's as it should be, right? But being able then to filter this view to look at a specific customer, so I could go down and add a filter and say, I want to look only at traffic that came in interfaces that are connected to Zavis, for example. And so now I can see, Zavis hands me off traffic in Chicago. Some of that hairpins back out of the same POP, and I hand it off to Microsoft or Telia. Other of that traffic goes across my backbone to New York and San Francisco, and I hand it off to these ASNs.
How I identify the customer? With the BGP ASN, right?
In this case, there's a bunch of ways you could do it in Kentik. The filter I applied just says the interface where that traffic ingressed has the word Zavis in the interface description. Or it could be a customer ID, or if you provision all of your interfaces with link IDs, you could set up a custom dimension in Kentik that matches interface descriptions and tags the traffic with a provider name or a customer name and do it that way.
That
right?
would be great, because if BGP ASN, then maybe they are using the ASN number, which you don't know.
Right, or they may have their own downstream customers with their own ASNs, right? So this is based on the...
And you can use communities, not just AS path. Every flow record has the entire AS path and community string at the source and dest. So however your policy is, you can match and apply that.
So this is great for, and these are the type of things that our customers, especially the product and the revenue people in these large wholesale networks, are looking at to understand on a customer by customer basis, how much does this customer cost me? What is the relative cost of transporting that customer's traffic based on how far I carry it across my network? And so in the past, if you're trying to provide pricing for a customer, you don't have this type of data available, so you have maybe an average cost per meg that you use across all of your customer base. Now you have the ability to differentiate your pricing based on the actual delivery cost of the customer's traffic, and that really gives customers Kentik's customers a leg up over competition because they can do this type of differential pricing that they haven't been able to do, whereas people who don't have this level of visibility have to use pricing based on average cost across all of their customers.
What if service provider has more than one ASN?
If they have more than one ASN, we can, because we're showing the traffic, we have data input from the routers across multiple ASNs. So it doesn't affect the way this is displayed, right? The routers that are associated with these POPs would all be incorporated into the view.
Shouldn't be an issue, but just I wanted to know. By the way, I like this solution right now, what you are showing actually.
Excellent. Very good to hear.
I missed it. What did he say?
I like this, especially this part.
Okay.
Yeah.
You like very.
So as a quick kind of Kentik UI refresher, the Data Explorer is kind of the ad hoc exploration part of the product, and so I can choose from all these different dimensions that we store. Right now, the 4 that we're displaying are the source AS number, the ingress site or POP, the egress site or POP, and the remote AS number at the other path. But I could pick any set of dimensions. I could look at source dest IP pairs, source dest prefix pairs, interfaces, custom dimensions that we've added on, geolocation stuff. So whatever I want in the output, I can just select it here. I can choose how to visualize that. So instead of aggregating across the time range of the query and showing a Sankey breakout, I can view it as a time series stack graph or a line graph to see how those different things changed over time. And then I can add filters to my heart's content too. So I want to filter on interface descriptions, prefixes, tags, BGP attributes, you name it, all very flexible to get exactly the output that you want to see, the thing that you need to see to answer the question that you have at that moment in time.
It shows me the path, but it doesn't tell me that this is suboptimal path, right? So it doesn't tell me whether this path is the suboptimal option, because maybe I am intentionally carrying some traffic in my backbone longer distance, so I am doing maybe cold potato routing in this case for the best exit, not the closest exit. So it shows me the path.
There's still, yes, this Data Explorer is really designed as an augment for operators to view and answer questions quickly, right? To ensure that your intent is being carried out on the network. We do have, and I'll show in the alerting section, where you can build policies to tell you when things have changed or when things have deviated from what's been observed in the past. But it is not it is not a full policy enforcement engine, if you will, right? Or policy detection.
Yeah, and now question. For example, can I say here, for this customer, I want to send their traffic to this POP, okay? For this IGW POP. And I specified that, and let's say there is some link failure, etc., and traffic is going to another IGW POP, another internet gateway size. So can I define this policy, and when there's a, let's say, failure in the network, link failure, node failure, whatever, can the Kentik alert me, now you are sending over the let's say, suboptimal path.
So we could, along a bunch of different dimensions, we could profile top paths per customer and then tell you if a path that wasn't seen in the past is now in the top end, right? So it's not necessarily saying, well, we know this is a suboptimal path, but we know it's not the path that was being used in the past,
This
right?
one can be shown, right?
Yeah.
You can get all changes, including the ones which are normal patterns that have gone away, which actually is often very interesting, which is what's a peer or what's a customer traffic pattern that's no longer there. In the enterprise, that more might signal you just applied a policy that broke something. In the service provider world, it's more about traffic management on the POP. And before we leave this, everything that you see here as you change things, all of these things in the UI are API also.
Yeah.
So anything that you do, you just click get the API, and as you make changes, it'll just tell you what the API is to get this, put it in other systems. So if you have a system that knows what you think the path should be or what the average distance is, it's very easy to use the UI, form the query, validate the data, and then just we'll give you the curl call, get that and put into your own scripts. And we have Python libraries that sync with our API. So the idea is we do all this augment and then you can use it. It's not trapped in Kentik. It's for use with your other systems as well.
So the Data Explorer is great for, I've got a question, I need an answer. But a lot of times what people do is use the Data Explorer to create dashboards. We also have a bunch of dashboards built in out of the box. So just like anything I construct in the Data Explorer, I can get an API call for it. I can also add this to a dashboard, and then on a dashboard have, refresh, so we get the white instead of the dark. On a dashboard have a bunch of queries that I've built in the Data Explorer sort of side by side on the same page. So this is a dashboard that illustrates some of the stuff that we were talking about in the OTT and CDN augmentation of the network traffic data. So the top graph is showing me traffic that originated from OTT services versus non-OTT services. And this is a real service provider network we're looking at here, although part of their edge, not their entire edge. So there may be, this may be skewed one direction or the other if we were looking at their entire edge.
Nice amount of traffic they have.
And then breakdowns of ports and protocols, originating CDNs, originating OTT providers, and traffic types. So how much of the traffic was associated with storage services, gaming, social, video, different ways to break that out. This is sort of an interesting graph. So these are top consumer IPs on the network. This network has a mix of business and residential customers on it, but I can see who are my top gaming subscribers, just sort of at a glance for the time range of this report, who are the top consumers of storage services.
And where is that engine running?
Where is the engine?
Yeah, the rendering engine, because it's very fluid, very smooth.
The rendering engine's running in the browser.
Yeah.
So the browser gets the raw data from our backend, the kind of row by row data, and assembles it here.
Very good job. It's very smooth, and based on the fact that you have many information on a single web page.
We actually have in the back end, and we're not doing the geek talk about the entire back end this time, but it's in previous networking field days that are on our YouTube channel and Tech Field Days site about it. But it's actually interesting. Each one of these dashboards, each panel can be multiple queries, and we can have hundreds of users for each of hundreds of customers. So it's not only a lot of data, but we have to make sure that one user doesn't swamp it. And so it's JavaScript, React. That's about all I know. I'm a back-end and network guy, running, and it uses the same APIs that you use. Basically, when it's showing you the API call, it's using the similar APIs to get data from the back end as it's rendering.
So from the dashboard, I can jump back into the Data Explorer by clicking on the name of a panel. Then I get that individual panel full size in the Data Explorer, and I could add filters in this. So I could add a filter saying want see OTT service type. And then I can get the results just for that type of traffic. So it does allow me to drill down, filter, get just the view I need for the question I'm trying to answer at that particular point in time. I did mention alerting, and I'll cover that quickly. So we can create policies or choose policies from pre-built policy library. And the policy engine is very much like the Data Explorer in that I can choose what dimensions this policy is going to look at. So I could look at source dest ASN pairs across my network. And I want to measure bits per second for each source dest ASN pair. I want to have a threshold that looks at the top 25 ASN pairs from my current traffic set and compares it to the top 100 ASN pairs from my historical traffic set. So if I see anything that moves into the top 25 that wasn't previously in the top 100, that's a pretty interesting event, right? I've got some new traffic flow across my infrastructure that wasn't there before. And so this is the mechanism that you asked about before. I could choose, instead of source dest ASN pairs, I could choose customer and path, or I could choose ASNs per pop or geographies for per pop if I'm a CDN provider, so that if one of my CDN pops that's based in New York starts serving traffic to Europe, I can get an alarm about that as a potential misconfiguration. So it's a really super flexible policy engine. And then there's timers and stuff, so I don't want an alert the first time that happens. It has to happen 4 times in 2 hours, or to keep make sure that the alarms we generate are really actionable. And then I can choose what am I going to do about that. I can make an outbound API call. I can email PagerDuty, OpsGenie, send a Slack message. All of these integrations about how we're going to notify you about that. And then there's historical baseline options too. So instead of top 25 versus top 100, I could look at time series data. For any given item, ASN, IP, whatever it is based on the dimension, does the traffic volume that it's producing now, is it above or below what it's done historically? Generate an alarm about that. So the last thing I'll show you on the service provider side is the my Kentik white label portal. So the configuration for that is here in the admin menu. I can upload a logo to customize the login. I can set what the custom URL is for my downstream customers. So this is a fictional company called Acme Telecommunications. The URL for their customers to log in is acme.my.kentik.com. I can put support and URL email in there. And then I can configure tenants in the UI right here. So if I look at this tenant, they have access to see traffic across these devices. So you might choose only the edge devices, the access edge devices where that customer has links terminating, and then further restrict them only to traffic that's to or from the IP block that's assigned to them, or to the physical interfaces that they have connections to. So when they log in, all of the traffic that they're able to see is filtered only to these restrictions. And then I also have the ability to open the view as them. So this is the UI that they would see if they logged in. And you'll see there's a reduced set of menus here. They have only a few pre-built reports that they can select from, not the full ad hoc view of the Kentik UI.
By the way, it seems that this might have a good use case for not only ISPs, but for the IXPs as well, Internet Exchange Points.
Absolutely, and we have a number of existing customers who
IXP,
are
right?
IXPs and a number who are somewhere in the sales pipeline. And this is what what the login page would look like for a downstream customer.